So in today's video, I'm going to be going over 20 of the hardest math SAT questions that you might see examples of on your SAT this March. What I'm going to do is I'm going to take you through these questions, how to solve them, and then also talk a little bit about the underlying concepts that you need to understand before you even solve these difficult questions. So if you guys enjoy this video, make sure that you comment, like, and subscribe to the YouTube, as well as following Teen Tutors on Instagram and TikTok. We post practice questions daily, and we also post review videos as often as we can. So without further ado, let's get into the first question. So the first question is from practice test 1. It is question 15. We're given an equation 5g plus 45r equals 380 and told that at a school fair, students can win colored tokens that are worth a different number of points depending on the color. We're told that one student won G green tokens and R red tokens worth a total of 380 points. We're told the given equation represents a situation. How many more points is a red token worth than a green token? So the reason why this question is difficult is because a lot of the time students will try and start solving for G and R. And what you need to realize is that in an equation, if you are given two unknowns, so here we have G and R, you need two equations in order to solve G and R. That's why when we have 4x plus 1 equals 3, we can solve that because we only have one unknown, the x. So we can solve for x with just one equation. But here we have two unknowns, which means we need two equations to solve for G and R. But we don't have a second equation. So what you should be thinking to yourself is, okay, I don't need to solve for G or R. I just need to understand what's going on in the equation. So we're told that 380 is the total number of points. So if we write this out, we're going to have 5 times, it tells us that G is the amount of green tokens. So number of tokens, it doesn't even matter if it's green or red, plus 45 times the R is the number of red tokens. So number of tokens, and that's going to equal the 380 points. So if we have to equal 380 points, you should be thinking, okay, 45 and 5 are probably equal to the number of points that each the G green tokens are worth and the R red tokens are worth. So that's actually what it is. So each green token is worth 5 points. So the G is worth 5 points. And then the R, the red tokens, are each worth 45 points. So then the question asks, how many points is a red token worth more than a green token? So literally all you would have to do is 45 minus 5, and the answer is just going to be 40. So that's the answer to our first question. So the next question we have here is also from SAT Practice 1. We are looking at question 22, where we're asked, in the xy plane aligned with equation 2y equals c, for some constant c intersects a parabola at exactly one point. If the parabola has equation y equals negative 2x squared plus 9x, what is the value of c? So what we could do is we could plug this into Desmos and just start plugging in numbers of c. But when we're asked for constants of c, it's very common that you might get an answer for c. Let's say you might think it's 8, but the answer is actually 9. Sometimes you'll get really close to the answer if you try to do it in Desmos, and it'll look correct, but it'll actually be incorrect. So if we look at this, let's try and actually understand what's going on here. So if we have in the xy plane a parabola, so I'll just draw a parabola like this. The only time that this parabola will intersect a straight line, because if we have 2y equals c, then this is equal to y equals c over 2. And c is a constant, so this is just y equals a constant, which means that we're just going to have a straight line. Okay, so the only time that that will intersect our parabola will be if it is a straight line at the vertex. So what we need to do is we need to find the vertex of our parabola. So what we're going to do is we're actually just going to put it into Desmos. We're going to say y equals negative 2x squared plus 9x. And that's going to be the y value for our function. So we have that our y is going to be 10.125. So if we draw this, our parabola is going to look like this. And then we're going to have a straight line at the y value of 10.125. So what we need to do is we need to say, okay, well then what is c here? So if y is equal to 10.125, then 2y would equal 2 times 10.125, which would equal 20.25. So that would mean that C would equal 20.25. So our answer to the second question is 20.25. So our next question is question 21 from practice test 1. We're asked for groups of 25 or more people. A museum charges $21 per person for the first 25 people and $14 for each additional person. We're asked which function f gives a total charge in dollars for a tour group with n people where n is greater than or equal to 25. So a lot of people get these questions wrong because they don't know the general formula for these equations. So when we're told that a charge or a slope is basically what this charge is, because we have $21 per person, and that is a slope. What we need to do is we need to evaluate the first slope or the charge per hour. So the first one here is, it's actually going to be a charge per person. It's going to be $21 per person. And the second one is $14 per person after n equals 25. So what we need to do is we're going to write this in the form of y equals mx plus b. And in this equation, we have n instead of x, so it'll just be y equals mn plus b. That doesn't really change the general formula we're going to use. And so what's going to happen is our slope, our m, is always going to be the second amount, okay? So we're going to have m equals 14. So we're going to have y equals 14n. So immediately c is incorrect. And then what our b is, we are always going to do the difference between these two slopes. So slope 1 was 21 and slope 2 was 14. So we're going to do 21 minus 14, and then you multiply that by how many times you use that slope. So the first 25 people, we used 21. So we're going to multiply that by 25. So you're going to get 14n plus 7 times 25, which would give you 14n plus 175. So the answer to this question is A. So the next question we have is question 21 from SAT Practice 2. We're given an equation and told that in this equation C is a positive constant, and then we're asked which of the following is one solution to the given equation. So what we should realize here is that our bottoms for these two fractions are the same, which means that we can add or subtract these fractions without having to move anything around, without having to multiply anything. So what we would do first here is let's first even understand that we need to get x by itself. The solution is the x value that will make this true. So what we need to do is we need to get x by itself. So what I realize when I look at this question is that we can add or subtract these fractions because they have the same bottom. And what's going to happen is if we wanted to add or subtract these fractions, we would subtract them, right? Because we would move this term over here. And then you would realize that the top would be x squared minus c squared, and the bottom would be the square root of x squared minus c squared. And so we're going to see how that's going to affect the question. So we can make this x squared over the square root of x squared minus c squared. And I'm going to subtract c squared over x squared minus c squared. And then that's going to equal 39. So what I can do now is I can merge these fractions. I'll have x squared minus c squared over the square root of x squared minus c squared. And that will equal 39. And so what we need to realize is that in an equation, if we have any number, let's just say 3 to the power of 5 over 3 to the power of 2, that's going to equal 3 to the power of 5 minus 2. So what's going to happen here is we can model this as x squared minus c squared to the power of 1 over x squared minus c squared to the power of 1/2. So that's going to also still equal 39. And so what we can do is we can say that this is just going to be x squared minus c squared to the power of 1/2, and that's going to equal 39. So that means that we can say that the square root of x squared minus c squared will equal 39. And so now let's start getting x by itself. So I'm going to continue over here. So if we have the square root of x squared minus c squared, and that equals 39, we can square both sides, we're going to get x squared minus c squared equals 39 squared. And in our answers, we have 39 squared here, so I'm not going to evaluate 39 squared. I'm just going to leave it like that. So then to get the x by itself, now we can add the c squared to the other side. We'll get x squared equals c squared plus 39 squared. And then now to get x by itself, we can square root both sides. Now be careful, when you square root both sides, your answer is going to be positive or negative. Why is that? Well, what is the square root of 9? That equals 3. But it also equals negative 3, because negative 3 squared is 9. So we can say that x will equal plus or minus the square root of c squared plus 39 squared. So our answer will either be positive square root of c squared plus 39 squared, or it'll be negative c squared plus 39 squared rooted. So it looks like our answer here is going to be D. Okay, so our next question is also from SAT Practice 2. It is question 22. And in this question, we're given an equation of f of x equals ax squared plus 4x plus c, and told in this given quadratic function, a and c are constants. We're then told that the graph of y equals f of x and the xy plane is a parabola that opens upward and has a vertex at point h comma k, where h and k are constants. Then we're asked if k is less than 0, and f of negative 9 equals f of 3, which of the following must be true? So with these questions, where you are asked to evaluate a function based on things equaling each other and based on h and k, based on a vertex, you should probably think about a vertex formula. So what we need to understand is that here, f of negative 9 equals f of 3 and k is less than 0. That's going to mean that our vertex is somewhere negative, right? The y value is somewhere negative. The x value could be anywhere, but the y value is somewhere negative. And the x value is going to be in between our zeros. When we have a function, so here we're going to be at f of negative 9 equals f of 3. So let's just say that that's here and here. And those equal each other. And then our vertex is somewhere down here. The distance between the vertex and each of these points is the same. So what number is in between negative 9 and 3? Well, we could do negative 9 plus 3 over 2. We would get negative 6 over 2, which would give us negative 3. So negative 3 is in between both of these points. It's 6 away from both of these points. So our x value for our vertex is negative 3. So if we wanted to plot this point, we could just plot it somewhere like here. Again, it doesn't matter what our actual y value is of the vertex as long as it is negative. So then if we draw this parabola, it should look something like this, because it says that it opens upward. Okay, so we can write this in vertex form as a times x plus 3 squared minus or plus k, where k is negative, but we're just going to leave it at plus k because we're going to realize, okay, k is negative. And if this part doesn't make sense, well, this is just the vertex formula of a times x minus h squared plus k. So let's expand this out and see what we get. We're going to get a times x plus 3 times x plus 3 plus k. So we're going to get a times x squared plus 6x plus 9 plus k. So we're then going to get ax squared plus 6ax plus 9a plus k. And we're asked which of the following must be true. So let's take a look. Well, we have that a has to be greater than 0. Why is that? Well, the parabola opens upward. So we know that a has to be greater than 0 because if the parabola opens upward, a will be greater than 0. And if it opens downward, then a will be less than 0. So here we can say that, okay, let's now worry about c. We don't know whether or not the fact that a is greater than or equal to 1 is true, but we should probably look at c first because we kind of know about what the situation is with a. So with c, our c term here, if we write this out, this is going to be equal to ax squared plus 4x plus c. So we have that 9a plus k is our c term here. So we have that 9a plus k equals c. So we know that c is negative, okay, but we don't know what negative it is. We also aren't sure yet what a is. So let's look back and see, can we solve for a? Well, we actually can. We need to understand that for these equations to be the same, each term needs to equal each other. So for our 6ax, that's going to have to equal 4x. So I'm going to write over here 6ax equals 4x. So 6a needs to equal 4, which means that a is 4 over 6. Which means that now we actually know that 2 must not be true. Okay, we know that a is equal to 4 over 6, which is not greater than or equal to 1. So immediately this is wrong, this is wrong. So now let's look at C. So we can plug A in for this. We're going to get 9 times 4/6 plus K equals C. So we're going to get 9 times 4 is 36 over 6 is 6. So 6 plus K equals C. Now, we don't know what K is. K just has to be negative, as I said at the beginning. So K could be -1. K could be -2. It could also be -17,000. It could be any negative number. We don't know, which means that we cannot be certain that C is less than 0. Okay, it could be, but it's asking which of the following must be true. So we're not certain that C is less than 0, which means our answer has to be D. So our next question is from SAT Practice Test 3. We're given an equation x minus 29 equals x minus a times x minus 29, and we're asked which of the following are solutions to the given equation where a is constant and a is greater than 30. So again, we need to realize that the solutions are the x values that make the left side equal the right side. So all we have to do is plug these values in for x and see if we get the left side equaling the right side. So for case 1, where x would equal a, because again, this is the x values that would give us our solutions, we would have a minus 29 equals a minus a times a minus 29. So we would have a minus 29 equals a minus a is 0 times a minus 29, which means we would have that a minus 29 equals 0. So a would equal 29 here. This is impossible because a has to be greater than 30. So this answer choice is incorrect. Now for case 2, we have a plus 1 equals x. So we'll plug in a plus 1 minus 29 equals a plus 1 minus a times a plus 1 minus 29. And we're going to get a minus 28 equals a minus a is 0. And then plus 1, we just have 1. And then here we would also have a minus 28, which means that we're going to just have a minus 28 equals a minus 28, which is true. This is true for all values of a. So the case 2 is true. Now for the third case, we're going to have 29. So we'd have 29 minus 29 is going to equal 29 minus a times 29 minus 29. So we're going to have 0, because 29 minus 29 is 0, equals 29 minus a times 0, because 29 minus 29 is 0. So we have 0 equals 0, and this is true. So the third test case is also true, so we should look for an answer that says 2 and 3 only, which is C. Now our next question is question 15 from SAT Practice 3. We're given a long equation that equals 0, and as in this given equation, p is a positive constant. The sum of solutions to the equation is 20 over 3, and then ask what is the value of p. So let's evaluate all of these separately. So first, let's evaluate 3x plus p equals 0. So we're going to get that 3x equals negative p. And again, similar to the last question, let's remember that we are looking for the x values that will make these true. So we're going to get x equals negative p over 3. So that's the solution for that. Now we have 5x squared minus 45 equals 0. For that, we're going to have 5 times x squared minus 9 equals 0. This is a difference of squares. So we'll have 5 times x plus 3 times x minus 3 equals 0. So our solutions are negative 3 and 3. Now for the last equation, we're going to have 2x squared minus 16x plus 3p. So then we're going to have 2 times x squared minus 8x plus 3 halves p. Now, we should realize that for an equation, the sum of solutions is just negative b over a. So the sum of solutions is just going to equal negative b over a. So we don't even have to do any of this. This part is useless. We could literally have just done negative b, which is positive 16, over a, which is 2. So that's the sum of solutions to this one. So if we add all of these up, we would get negative p over 3, minus 3, plus 8, and that equals 20 over 3, which is the total sum of solutions. So this negative 3 and 3 will cancel. We'll get negative p over 3 plus 8 equals 20 over 3. We can subtract the 8 from both sides, get negative p over 3 equals 20 over 3 minus 8. So then we would get that negative p over 3 equals 20 over 3 minus 24 over 3, so that we can subtract these fractions. So negative p over 3 is going to equal negative 4 over 3, which means that negative p will equal negative 4. So p will equal 4, and our answer is 4. So the next question is question 17 from SAT Practice Test 6. We're asked, a rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. Then we're asked the diagonal of the rectangle is twice the length of the shortest side, and the area of the rectangle is 1089 square root 3 square inches. We're then told what is the length in units of the diameter of the circle. So let's draw this circle. So this is our circle, and we're told that there is a rectangle inscribed in the circle, which means it's going to look like this. Now, if we draw a diagonal through the center, that is going to be our diagonal for the rectangle, but also the diameter of the circle. So we're told here that the diagonal of the rectangle is twice the shortest side. So how about we call the shortest side x, and we will say that this is double that. Now, you should hopefully realize that this makes this a 30, 60, 90 triangle. Usually when a square is inscribed in a circle, it will be two 45, 45, 90 triangles if you split it in half. Here with the rectangle, it's usually a 30, 60, 90 triangle. So we're going to have a 30 here, a 60 here, and a 90 here. Why is that? Well, because we know that across from the 30 is x, across from the 60 is now going to be x root 3, and across from the right angle is 2x. So we know that the area of this rectangle is just going to be x times x root 3, because that's length times width. So x times x root 3 here is going to equal 1089 root 3. So we can cancel out these root 3's and make this x squared. So x squared equals 1089. So x here is going to equal the square root of 1089. So if we go to our calculator, we could say square root of 1089, and that's going to be 33. Now, like I said in a previous problem, technically it's plus or minus 33, but in the context of this problem, we can't have a negative length, so x is going to equal 33. So now that's what is the diameter of the circle? Well, the diameter of the circle is 2x. So 2 times x would be 2 times 33, which would equal 66. So our answer to this question would be 66. So our next question is question 20 from Practice Test 6. We're given a table and told that this shows values of x and the corresponding values of g of x, where g of x is equal to f of x over x plus 3, and f is a linear function. Then we're asked what is the y-intercept of the graph, y equals f of x in the xy plane. So what we should do is let's try and find what f of x is relative to g of x, because we know what g of x is, and for all of the g of x values, we know what x plus 3 is because we're given it. So we could write that since g of x equals f of x over x plus 3, then g of x times x plus 3 will equal f of x. So we know that f of x is a linear function, so all we have to do is find 2 points, and then we could write slope formula. So let's plug in some values. So we could say that g of negative 27 times negative 27 for our x plus 3 is going to equal f of negative 27. So we would get g of negative 27 is 3, and then negative 27 plus 3 is negative 24, and that equals f of negative 27, and that equals negative 72. So that gives us the point negative 27 comma 72 negative. So we can then plug in another point. Let's just plug in negative 9 comma 0. So we're going to have g of negative 9 times negative 9 plus 3 is going to equal f of negative 9. And g of negative 9 is 0, so we're going to get 0 times negative 6 equals f of negative 9, and that just equals 0. So this gives us a point negative 9 comma 0. So now we can write this in the form of y equals mx plus b, where our slope would be rise over run. We would do y2 minus y1 over x2 minus x1 with these 2 points. So we're going to have 0 minus negative 72 over negative 9 minus negative 27. That's going to equal 72 over negative 9 plus 27, which is 18. and that's going to give us a value of 4. So we have y equals 4x plus b. And now we can just plug in a point. I'm going to plug this one in to find our y-intercept, because our y-intercept is our b value. So we would have 0 for our y equals 4 times negative 9 plus b. So we would have 0 equals negative 36 plus b. So 36 equals b. So our answer here would be 0, 36, which means our answer is A. So the next question is question 21 from SAT Practice 6, and we're told a circle has center G and points M and N lie on the circle, and then we're told line segments MH and NH are tangent to the circle at point M and N respectively. We're told if the radius of the circle is 168 millimeters and the perimeter of the quadrilateral GMHN is 3,856 millimeters, we're asked what is the distance in millimeters between points G and H. So if we draw this circle with center G, and then we have 2 points on this circle, let's just call them M and N because that's what we're told, and they meet their tangent lines, which means they are tangent to the circle at the point that they come out. They meet at some point H, so at this point H. So what we need to realize is that, first of all, the distance from G to M and G to N is the same because they're both a radius. So this is going to be 168, and so will this. We also have to realize that if 2 tangent lines of a circle meet at the same point, those also have the same distance. We should also realize that the lines that are tangent to the circle are right angles to the radius. So we're going to basically have 2 right triangles. But before we do that, let's find x. So we know that 3,856 is equal to the perimeter. So it would be 2 times 168 plus 2 times x. So we'd have 2 of these sides that are x. So we can say that 3,856 equals 2 times 168 plus 2x. And if we zoom out, we're going to get that x is going to equal 1,760. So x equals 1760. So now we can say that this will be 1760. And so we can find this distance, I'll just call it d, by using the Pythagorean theorem. We could say 168 squared plus 1760 squared is going to equal d squared. So the square root of 168 squared plus 1760 squared equals d. So if I go in here, I'll say the square root of 168 squared plus 1760 squared. And I'm going to get 1768, so the answer is D. Okay, so the next question is also from practice test 6. It's question 22, where we're asked the function f is defined by f of x equals ax squared plus bx plus c, where a and b are constants. We're asked the graph of y equals f of x in the xy plane passes through the points 7, 0 and negative 3, 0. We're asked then if a is an integer greater than 1, which of the following must be the value of a plus b. So we are again given 2 points of a parabola that equal each other. So we have 7, 0 and negative 3, 0. So we are told that a is greater than 1, which means that we're going to open up. And then we can also realize that, okay, well, the vertex, the x value, will be in between 7 and negative 3. So 7 plus negative 3, so minus 3 over 2 would equal 4 over 2, which is 2. So the x value here is 2. So our parabola might look something like this, where this is at x equals 2. And so let's write down our equation. So we're going to have a times x minus 7 times x plus 3. That's just how you would write the factored form. Always remember, you do need to have that a in front. So we have a times x squared plus 3x minus 7x, and then we would have minus 21. So we'd have ax squared minus 4ax minus 21a. So this is our a value and this is our b value. So a plus b is going to equal a minus 4a, which is going to equal negative 3a. And we're told that a is an integer greater than 1. So let's just start plugging in integers greater than 1. We would start with 2. So negative 3 times 2 would equal negative 6. Negative 3 times 3 would equal negative 9. Negative 3 times 3 would equal times 4, my fault, should be negative 12. And so we should realize that we're just going to be incrementing by 3, and as long as the number is -6 or greater, then it's correct. So the only number here that is at least -6 and is divisible by 3 is actually -6. So our answer here is A. So the next question is question 13 from SAT Practice 7, where we're asked, in a set of 4 consecutive odd integers where the integers are ordered from least to greatest, the first integer is represented by x. We're then told the product of 12 and the fourth integer is at most. So the next question is question 13 from SAT Practice 7, where we're asked, in a set of 4 consecutive odd integers where the integers are ordered from least to greatest, the first integer is represented by x. We're told the product of 12 and the fourth odd integer is at most 26 less than the sum of the first and third odd integers. Then we're asked which inequality represents the situation. So we should realize that our consecutive integers would be x, comma, x plus 2, because they're only odd, so we would have to add 2 instead of x plus 1, then x plus 4, and x plus 6. So this is the first term, this is the second term, this is the third term, and this is the fourth term. So the product of 12 and the fourth odd integer, so that would be 12 times the fourth odd integer is x plus 6. That is at most, which means it has to be less than or equal to 26 less than, so we're going to have a minus 26 in our answer. I'll put that at the end. So I'm going to put a star here and remember that there's a minus 26. The sum of the first, so just x, and the third odd integers. So plus the third one was x plus 4. And then we have to remember we are going to have that minus 26. So which equation looks like this? Well, it would be equation A. So our answer is A. Now the next question is question 20 from SAT Practice 7, where we're asked, for each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system. So this question is on practice test 10 and also tested on practice test 6. It's tested with different numbers on those two tests, but they have been putting this on practice tests recently. So what we need to do is we need to realize that these equations actually have infinite solutions. If we multiply this by 4, we would get 28x plus 24y equals 20, which means that they're the same. So we are not trying to solve these equations. What we need to do is, it looks here like we need to get either x or y as r and then find what y or x would be. So let's first solve for x and then we'll solve for y. So we're going to get 7x plus 6y equals 5. So we would have 7x equals 5 minus 6y. So x would equal 5/7 minus 6 over 7y. So what's going to happen is, if y equals r, then x will equal 5/7 minus 6 over 7r. So that point would give us 5/7 comma 6 over 7r. So that's our x value. And then our y value would just be r. Now, if we do this with finding y, we would have 6y equals 5 minus 7x. So y equals 5/6 minus 7 over 6x. So then we have that if x equals r, then y is going to equal 5/6 minus 7 over 6r. So this would give us the point of r, because that's our x. We said that if x equals r, then we would have 5/6 minus 7 over 6r. So our goal is to find an answer choice that has either this one or this one. So do we have 5/7 minus 6 over 7r for an x value? It looks like we do here, right? And then we have r for our y value. So this looks like it's right, but let's just check just to make sure that we don't have this. So we would have r, so these two have r, comma 5/6. So we have a 5/6 here, but the -7/6 is positive here. So that's incorrect. So our answer here is going to be D. So the next question is from SAT Practice Test 8. This is a very rare occurrence of them asking a histogram question, but it's important that we understand what a histogram is. So we're asked 2 data sets of 23 integers each are summarized in the histogram shown. Then we're asked, for each of the histograms, the first interval represents the frequency of integers greater than or equal to 10 but less than 20. Then we're asked, the second interval represents the frequency of integers greater than or equal to 20 but less than 30, and so on. Then we're asked, what is the smallest difference between the mean of data set A and data set B? So what we need to realize is a histogram is just a group of numbers and it groups them together. So for example here, there are 3 numbers in dataset A between 20 and 29, but we don't know exactly where they are. So we should realize these data sets have the same exact shape. It's just that data set A was shifted over 10. So what if we made these numbers in data set A as little as they could be for each of their boxes, and the ones in data set B as large as they could, so that each one would be one away from the other. So for example, all of the ones in data set A will now be 20. All the ones in data set B will now be 30, or all the ones in the 30 to 40. All the ones here will be 40, and all the ones here will be 50. And then here we're going to make them as much as they can. All these will be 19, all these will be 29, all these will be 39, and all these will be 49. So for each of our bars, they're just one away from the other one, right? 49 and 50, 39 and 40, and so on. So if that were the case, then our mean would just be one away, because on average, they're all one away from each other. So that is the smallest difference we could have here. The answer here would just be 1. It would just be B. So the next question is question 18 on SAT Practice Test 8. We're asked, in the given system of equations, R is a constant. We're asked, if the system has no solution, what is the value of R? So what we need to realize is that for a linear equation, which means we just have y and x, no x squared or any of that, for that to have no solutions, what needs to happen is we need to have the same slope and a different y-intercept. So what we need to have is we need to get y by itself and then make sure that the slopes are the same. So for the first one, for 48x minus 72y equals 30y plus 24, we can change that into, let's add the 72y to the other side and subtract 24. So we would get 48x minus 24 equals 102y. And then for the second equation, we already have it in terms of y, so we would have negative 16x plus 1 over 6 equals ry. So now let's get y by itself. For this one, we're going to have 48 over 102x minus 24 over 102 equals y. And for the other one, we're going to have negative 16 over r times x plus 1 over 6r equals y. So in these equations, always check to find the situation where the slope will be the same, because there are a ton of values for r where the b will be different, but there's only one where the slope will be the same. So remember, these two need to be the same. So 48 over 102 would need to equal negative 16 over r. So we could just put that straight into Desmos, where r would be x, because Desmos doesn't know what r represents. So we could write 48 over 102 equals negative 16 over x. And we're going to get a straight line at, if we look here, we're going to get a straight line at x would equal negative 34. So r would equal negative 34. So our next question is question 8 from SAT Practice Test 10, where we're given two data sets and asked which of the following must be true. So first we're asked about the median. So if we look at this, the median here, it looks like these are symmetrical, right? So they're symmetrical about here, right? We have the same amount of numbers on this side as this side, which means the median for data set A is 13. Now for data set B, it looks like they're also symmetrical about here. We have the same amount of points here as we do here. So 13 is also the median. So the median of data set A is equal to the median of data set B. But what about the standard deviation? Remember, the standard deviation is on average how far is each point from the mean. So if the shape of our data sets are not the exact same, as in if our points are not the exact same with the exact same numbers or with different numbers that are the same distances apart, as in this could be 10, 11, 12, 13, 14, 15, 16. This could be 20, 21, 22, 23, 24, 25, 26. It wouldn't matter as long as they're the same distance apart, and I will review that in another video. We know that the standard deviation cannot be the same. Why? Because if we just take a look here, well, the 10 and 16 values have different amounts. So right there, we found one difference in the shapes of the graphs. So instantly, that is incorrect. So the answer here would just be A, 1 only. So the next question is an interesting one. We're asked, the solution to the given equation is x comma y, and then we're asked what is the value of 8x plus 7y. So what we should realize is a lot of times what they're going to do is they're going to ask, for example, what is x plus 3? And they're going to put x plus 3 in parentheses. When they do this and they have in parentheses what they want the answer to, you can use something called substitution. So what I'm going to do here is instead of saying 8x, so instead of 8x, I'm just going to write it as x. I'm just going to write it as x. And instead of 8y, or instead of 7y, I'm just going to write it as y. So I can rewrite these equations as 2x plus 4y equals 12, and negative 2x plus 4y equals 12. And my answer is just going to be x plus y. Instead of doing 8x plus 7y, well, I'm going to tell myself, okay, well, 8x is x and 7y is y. So all I have to do is plug this into Desmos and find my answer. So we have 2x plus 4y equals 12. And then we have negative 2x plus 4y equals 12. And let's center this. And our solution would be 0, 3. So 0 plus 3 would just equal 3. So that's our answer. Our answer here is just 3. So in the next equation, we have a square inscribed in a circle. We're told the radius of the circle is 20 root 2 over 2 inches. And we're asked, what is the side length in inches of the square? So if we want, we can draw this circle, and we can also draw the square inscribed in. So in our next question, we have a square inscribed in a circle where the radius of the circle is 20 root 2 over 2 inches. And we're asked, what is the side length in inches of the square? So what we could do here is, if we draw our circle, we can then draw a square inside of the circle. And this square, if I could draw it properly, this square will have a diagonal, let's just leave it like that, with a diagonal of not 20 root 2 over 2 inches. It will actually have a diagonal of just 20 root 2. Why is that? Well, the radius of the circle is 20 root 2 over 2, so that's only half. The actual diagonal is the diameter, so we have to multiply that by 2. So we should realize that in a square, both of these sides are the same. So what we need to do is we need to realize this is a 45, 45, 90 triangle. As I said earlier, when we have a square inscribed in a circle, it's going to be two 45, 45, 90 triangles. So in a 45, 45, 90 triangle, we have x, x, and x root 2. So we have that x root 2 here equals 20 root 2. So we have that x just equals 20. So our answer here is just A. It's important to remember that for special right triangles, you need to make sure you can recognize them. A lot of people neglect recognizing special right triangles, but it is very important on this exam that you understand that if we have x, x, and x root 2, it's a 45, 45, 90, and vice versa, as in if we have a 45, 45, 90, it's x, x, and x root 2. And for a 30, 60, 90 triangle, across from the 30 would be x, across from the 60 would be x root 3, and across from the 90 would be 2x. And here we have 45, and this is a 90. So the last question we have here is, if we have this equation, what is the value of q? So what we should do first is let's get q by itself here. We're going to have 20 over p. We would add 20 over r plus 20 over s equals 20 over q. Now we can multiply everything by q, and we're going to get 20q over p plus 20q over r plus 20q over s would equal 20. Now we're going to do the same thing for all of these fractions. So we're going to multiply everything by p. We're going to get 20q plus 20qp over r plus 20qp over s is going to equal 20p. Do the same exact thing for the s, or for the r we'll do first. So 20qr plus 20qp plus 20qpr over s equals 20p, and we would multiply that by r. And then now we could finally do that with the s. We're going to get 20qrs plus 20qps plus 20qpr equals 20prs. So we can cancel out all of these 20s, because if we have the same number in front of all of the variables, then we could just cancel it out, because if we factored out a 20 from both sides, they would just cancel out. So now we can factor out a q. We're going to get q times rs plus ps plus pr equals prs. And then now if we divide both sides by this to get q, we're going to get that q equals prs over rs plus ps plus pr. So our answer here would have been C. Now, we could have just done this in our calculator. How can you do this? Well, what if we had said that p was equal to x Q is equal to Y, and then we could just say that R and S are equal to numbers. So R is equal to 2 and S is equal to 3. So we would have in our calculator then that 20 over X equals 20 over Y minus 20 over 2 minus 20 over 3. And then if we had plugged in all of our answer choices, this one would give us the same exact line. So if we look here, if we have PRS, that would be X times 2 times 3, so it would be 6X over, and I should mention that we would have Y equals because Q is Y. And then, so our RS would be 2 times 3, so 6. Our PS would be 3 times X, so plus 3X. And then finally, our PR would be X times 2, so it would be plus 2X. And if you look, this gives us the same exact equation. So we could have also done it in Desmos. So the final question I have for you is, are you ready for the SAT? If the answer to that question is no, you guys should really check out all these videos we have on our YouTube, Instagram, and TikTok. And you should make sure to subscribe on YouTube and follow Teen Tutors on TikTok and Instagram so that you can make sure to stay updated with all of our SAT posts. We know that the SAT is stressful, and so it is our goal to make it as simple and enjoyable for you guys. Thank you guys, and we'll see you in the next one.